Hi friends, and welcome to another fun episode. We continue from the last video by expanding our functionality for our structural column by creating a column foot family. As shown in the picture found at Pinterest, we will explore two different methods for displaying this column foot. In the first approach, we will load the family directly into the project and place it accordingly. For the second method, we will nest the foot family within the structural column family and establish a yes-no visibility parameter to control the visibility of the foot in the main project. We start a new family. This time it will be a classic metric generic model family. This creation will once again employ the blend function. The core geometry of the blend will mimic the column's cross profile, and in addition, plates at both the top and bottom will be placed. Okay, so we now have a blank canvas to craft our column foot masterpiece. Drawing up the skeleton of the foot with the reference planes, starting with the thickness, then the width for both and top plate and cross profile. We mirror it around the center line and again around a 135% angle. The length width will be the same from the left to right and top to bottom. And go into family types to create the parameters. We add the foot height, we make them type parameters so we can connect them later when we nest this family into the structural column family. We will have the foot thickness. We will also add foot width top, and of course we will have the foot width bottom. We place all the parameters in the dimensions group. We will also have foot material that will be placed in the material group. Now let's move on to create the dimensions. This will be for the thickness. This will be for the bottom cross-section profile, the top cross-section profile for our blend. We do the same for our top to bottom geometry, the thickness, and just put it out there, make them, no, that's, yeah, correct. That's look pretty nice. But first we just change the scale a little bit. We clean it up to make it more presentable and easy to read. Now let's move on to creating the geometry using our blend tool. The blend tool seamlessly merges two profiles or boundaries together. In our case, we have a large cross at the top and a smaller one at the bottom, which will blend together when finished. We start by working on the bottom profile. I recommend positioning these elements, lines, when creating the geometry adjacent to the reference planes rather than directly on top of them for better control during the alignment. We turn on the fast forward when aligning it because it is a bit of a tedious job. That's all done. We now go to the 3D view to check out the geometry. We go to the front view to set up the reference planes for our plate thickness, height of the blend, and plate thickness for the bot. We put up some dimension lines. And we connect the dimension lines to our parameters. Let's go back into the parameters and create a foot height. We already created a foot height, but this will be the foot height that is between the top plate and the bottom plate. So it will be a formula based on the foot height and the foot thickness. So we type in foot height, which is the total height of our foot, minus the foot thickness times 2. So this will be the height of our blend. We type in some numerical values. We connect the foot height, the calculated foot height. We drag it the blend down and align it to the appropriate reference plane. We go to the 3D view and we try to flex it. Okay, so the height is working, but the thickness is not. So let's see. Yeah, of course. It's because I forgot to connect the parameters to the dimension lines. How embarrassing, hey? So we go to the plan view and we start to connect all our dimension lines with our created parameters. So when changing the parameters value, the reference will adjust accordingly and take the geometry if aligned with it. And now it seems to work as I intended. We go back to the reference planes and we will proceed to create the top and bottom plates using the good old extrusion tool. The plates will be circular. We create the circle and we create an annotation for the diameter of the circle and connect an already existing parameter, foot width top, so they perfectly match the width of the top of the cross profile. We go to the front view and connect the plate with our reference planes we created. We do the same again for our bot plate. We align them to the bot ref planes. Very nice. Seems like we forgot to add the annotation for the diameter. We add it. We connect it to the parameter as we have done before. We press OK. We go to the 3D view to watch our masterpiece and voila. We select all the items connected to a material. And that's pretty beautiful. Manage. We purge it before we load it into the main project where our structural column is placed. Save it first, of course. We place it out near our column. We go to the plan view so we can move it accordingly. So we move it center to center, from center foot to center column. So it's placed as we want. Pretty nice. We need to adjust our parameters so it matches the column's parameters. So the column bot width will be the same as the foot top width. And we do a little bit of flexing just to make sure we got all the parameters correctly. Seems like it works pretty well. Yes. So let's do it another way. We open the structural column and then go back to the column foot family and load it into the column family. we nest the column foot family. We place it out in the family and align it to the center of the family in a plan view. Make sure you hit the center to center. Can be a bit difficult with all the reference planes, but we manage. We also align it in the Z axis to the correct level. There we go. We go into the parameters window. We create now a visibility yes no parameter. It means it's a switch on and off that will show a column with a foot if yes, and without a foot if no in the main project. We then add the parameters we want the end user to modify in the main project from the column foot family and give them numeric values. We want the foot width but we don't want the foot width top, because that is the same value as the column, as the cross width bot. Locate the foot family in the project browser tree and associate or connect the type parameters from the nested family to the instance parameters in the hosted family. This allows the end user in the main project to edit them, making this family fully parametric. So we connect all our parameters, type parameters in our foot family to the appropriate instance parameters. Absolutely great. That seems pretty cool, don't it? We load it into the family. We load it into the main project. Overwrite the existing family. We delete the other foot family loaded in previously, and we start testing it. We check off the foot visibility. That's weird. It should work. Yes, of course. We mark the object, the foot, and connect visibility to our visibility parameters that we forgot. And now we check the foot visibility again, and it works. We test the other parameters to see if they change, if it works. Pretty neat, pretty beautiful. It's a masterpiece. This concludes this tutorial. I would like to thank you for watching, and please like and subscribe. It will help me out a lot. Thank you.